There's a less sophisticated but very important form of energy that we can get from sunlight in addition to electricity, which is just quite simply heating. Of course, that's one of the very obvious things that the sunlight does to the earth to begin with is it warms it up. And we need to keep things warm to be uh, healthy and survive in colder climates and overnight. And we like to heat water up for cleaning. And so we have a need for thermal energy. In the module on thermal energy, we talked about quality of energy and how thermal energy is a lower quality of energy because it's the disorganized movement of atoms and molecules in a substance, and higher quality energy is things like mechanical or kinetic energy or electricity, where we can use those for anything we want. At the same time, we do need some thermal energy. So if the sun is providing it for free, we might as well use it. So in this part, we're just going to remind ourselves about some of the ways that we can tap into that freely available solar energy. Of course, we're also familiar with the problem that sometimes you get too much of that free heating energy from the sun. Uh, in Florida, your car allows that sunlight energy to come in through the windows. It gets absorbed by your dashboard and the seats and the steering wheel, and they heat up. And the infrared radiation that tries to leave the car and convection is trapped inside the car, so it gets uncomfortably warm. So you can get too much of that thermal energy. So one of the uh, technological approaches to dealing with heating using thermal energy is to make sure that you get it when you want it and not when you don't. So this diagram just illustrates in a sort of cartoon fashion one way to design a house that just makes it more energy efficient. You have a south-facing window, and in the winter, the sun is lower in the sky, so you get more direct sunlight coming in through that window, and you can have a large thermal mass, that is some literally large mass on the floor that absorbs that solar energy and doesn't cool off quickly. So then overnight, that concrete slab is still warm. It was warmed up in the daytime and it keeps the house warmer at night. And on the other hand, in the summer, the sun is higher in the sky, and so you would have an eave on the house that would prevent as much of that sunlight coming in to keep it from becoming too warm. So it doesn't really look like much, but with intelligent design of houses and buildings, you can actually dramatically reduce the energy cost of operating that house. And of course, this applies to business and commercial structures as well, with careful, thoughtful design of where the sunlight is coming in over the course of the year, and the appropriate selection of materials to absorb sunlight to store thermal energy when you want it, you can really cut down on the heating costs and not drive up the cooling costs of structures. So this is just a couple of examples illustrating this house has photovoltaic panels on the roof, but it also has a design. You can see these eaves over the windows that are preventing sun coming in when the sun is very high in the sky and allowing a lot of sunlight to come in those south-facing windows when it's low in the sky. Uh, the Trombe wall is just another configuration of that thermal mass to collect the sunlight and store it as thermal energy in a big thing that keeps that energy long enough so that it radiates away over the course of the evening to keep the house warm. If you want to get a little bit more sophisticated about it, you can put a solar collector on the roof that is not a photovoltaic panel. It's not generating electricity, but essentially you're putting your thermal mass outside the house. And that way you don't need to worry about overheating the house. And also you don't need to worry about, maybe I can't have south-facing windows, but I've always got a roof. So you put a solar collector on the roof, And this solar collector has basically got a fluid with good thermal conductivity and thermal heat capacity properties. And the sun hits it and heats that fluid up, and that fluid stores a lot of thermal energy in it. And then, if you want to heat the house, you just run with plumbing, run that thermal energy through the walls of your house to warm the house up. But if you don't need it, you don't do that. So you don't have any problems with overheating. So here's an example of how that can work to provide hot water for a house. So you have your storage tank on the left for a hot water system. You have a solar collector on the roof that's got glass on the top to prevent heat from getting out but allows the sunlight in. And then you have a plumbing system that basically runs a fluid through that solar collector that gets it very hot and then cycle it down into the water tank where it's just in contact with the water and it makes the water warmer. You can provide electricity if it's not a sunny day. And you'll see a lot of these on roofs of houses as well. They look different than the solar photovoltaic panels. Um, let's see if we've got a picture here. They're going to look like a single panel on the roof of a house like this that you see in this picture. Usually just one single panel. It looks glassy. It doesn't have that sort of electrical look of the photovoltaic panels. And they're to supply a house's hot water. And believe it or not, in a basic residential house, a significant fraction of the electricity bill comes from providing hot water. And the other big chunk comes from air conditioning. So those are two big pieces, and it's just easy. It's free. You have to buy the system, but then the energy supply from the sun is free, and it cuts down on your hot water bill by about 80% on average. Another type of solar heating that you will see frequently in Florida and other places where you have a lot of swimming pools are solar thermal pool heating systems. And these are even simpler. They don't use any special materials, no special fluids with special heat capacities. You just pump the water from the pool up through a series of really thin black tubes on the roof of your house or on some array as shown in this picture, and they just cycle through those black uh, panels, and they're just rubber or plastic panels with the pool water flowing through it, and then back down into the pool. And because they're in the sun and they're black, they're absorbing a lot of sunlight. That warms that water up, and it's not going to get it warm enough where you could use it to run an electricity generating power plant. It's not warm enough that you would really want to use it for showering or washing, but it is warm enough to make the pool a lot more comfortable, and it's a lot cheaper and easier way to heat a pool than using electricity or gas.